The younger Dryas really ticks all the boxes as a worldwide disaster, which definitely involved sea level rise.
There is a line in the dirt that has been driving scientists absolutely mad for nearly 2 decades. It is barely a centimeter thick in some places. It shows up on 4 different continents, buried at almost exactly the same depth. And for years, researchers could not agree on what it meant, what caused it, or why everything above it looks so radically different from everything below. Below that line, mammoths, mastodons, giant sloths the size of cars. A human culture so dominant and widespread their tools turn up from coast to coast. A world so full of life, it almost doesn't seem real. Above it, gone. All of it.
The younger Dryas, when flooding did occur and when the Earth was subjected to events cataclysmic enough to extinguish entirely the megafauna of the Ice Age.
Almost overnight in geological terms. Now here is the part that changes everything. Elon Musk's AI system, GROK, was fed the complete dataset from the younger Dryas boundary layer. Every chemical signature, every isotopic anomaly, every sediment reading that researchers have argued over for 20 years. And what it returned was not ambiguous. It did not hedge. It did not produce the kind of careful academic language designed to leave every door open. It ran the numbers, cross-referenced the global data patterns, and reached a conclusion that a growing number of the world's top researchers are now saying out loud, something came from space. And it didn't just end the Ice Age, it reset the planet. Stay with me, because what follows is one of those stories where the more you look at the evidence, the more you realize the textbook version was never the whole truth. The world before the line. To understand why any of this matters, you need to feel the weight of what was actually lost. 14,000 years ago, the Earth was thawing. Glaciers the size of entire countries were retreating northward. Rivers were cutting new paths through freshly exposed rock. Forests were creeping into places that had been frozen solid for millennia. And across all of it, enormous animals were thriving. Woolly mammoths, mastodons, American camels, dire wolves, horses running wild across the open plains of North America, giant ground sloths so massive they could reach the tops of trees that no other animal could touch. The warming had been steady and measurable for thousands of years. The trend was clear. The Ice Age was ending. Life was spreading. By every indication, the planet was on a one-way trajectory toward the warmer, more hospitable world we know today. And then, roughly 12,800 years ago, something slammed that process into reverse. Temperatures across the northern hemisphere dropped sharply, not gradually, sharply. The ice that had been retreating began advancing again. Cold air swept back across regions that had only just begun to warm. And this reversal, this brutal interruption of a 1,000-year warming trend, lasted for somewhere between 1,200 and 1,400 years. Scientists named it the Younger Dryas, borrowing the name from a small Arctic wildflower whose pollen shows up preserved in the cold sediment layers from that era.
Definitely involved the swallowing up of lands that previously had been above water.
It is a gentle name for what was apparently a catastrophic event. Here is the question that has never been satisfactorily answered. What flipped the switch? What could interrupt a 1,000-year global warming trend so abruptly, so completely, and so simultaneously across the entire Northern Hemisphere? That question is at the heart of everything that follows. The 3 mysteries that shouldn't coexist. Here is where the story becomes genuinely unsettling, because the Younger Dryas cold snap didn't arrive alone. At exactly the same moment in the geological record, 3 separate catastrophes appear to happen simultaneously. Not close together, not roughly around the same time, simultaneously. First, the climate reversal itself. A sudden, abrupt, planet-wide plunge into cold after thousands of years of warming. Second, the megafauna extinction. North America lost the overwhelming majority of its largest animals. Dozens of species, mammoths, mastodons, saber-toothed cats, ground sloths, American horses, vanish from the fossil record in what feels, geologically, like a single afternoon. Third, the collapse of the Clovis culture. These were the dominant people of Ice Age North America. Their stone tools, beautifully crafted spear points with a distinctive groove carved up the middle, had been found from one coast to the other for centuries before this moment. And then, right at the younger Dryas boundary, their toolkit disappears. The culture either collapsed entirely or transformed so radically that nothing recognizable survives. Ask yourself this: what are the odds that three events of this magnitude, a climate catastrophe, a mass extinction, and the collapse of a continent-wide civilization, all happen at precisely the same geological moment purely by coincidence? Most working scientists, even cautious ones, will tell you quietly that the coincidence explanation doesn't hold up. If three things break at the same instant, something hit them all at once. The question is what? The black mat, the line that started it all. Archaeologists digging at Ice Age sites across the American Southwest kept running into the same thing. They would be excavating downward through the soil layers, carefully brushing away centuries at a time, and they would hit a dark band, almost charcoal-colored, rich in organic material, unmistakable once you knew to look for it. Geoscientist C. Vance Haynes spent years documenting this feature at site after site, and he gave it a name as practical as it was perfect: the black mat. The black mat is not just interesting for what it is interesting for what it divides. Dig below it, and you find a lost world: mammoth bones, mastodon teeth, the distinctive fluted spear points of the Clovis people, evidence of a thriving, active civilization surrounded by giant animals. Dig above it, and that world is simply gone. Not diminished, not in decline. Gone. The mammoths do not reappear in the layers above the mat. The Clovis points do not reappear. It is as though someone drew a line through time itself and erased everything that came before it. For decades, researchers documented the black mat as a fascinating mystery, but not much more. And then, in 2007, a group of scientists published a paper that changed the entire conversation. Their claim was this: the black mat was not just a natural accumulation of organic sediment. It was the residue of a catastrophe, a cosmic catastrophe. And they had the evidence sealed inside it to prove it. What GROK was fed: the complete evidence data set. This is where GROK enters the picture, and it matters enormously to understand what the AI was actually working with. The Younger Dryas impact hypothesis has been generating research papers since 2007. Over nearly 2 decades, teams of scientists on multiple continents have extracted and analyzed the boundary layer at dozens of sites. Each analysis produced data: chemical signatures, isotopic ratios, material classifications, geographic coordinates, precise dating. Thousands of data points scattered across hundreds of studies, much of it contested, some of it replicated, all of it demanding cross-referencing at a scale that challenges human researchers. What GROK did was ingest that full body of evidence and apply pattern recognition to the complete dataset, rather than evaluating each study in isolation. When you feed an AI system the kind of multivariable, cross-continental data that makes up the Younger Dryas boundary record, it doesn't have the human tendency to anchor on a single impressive finding or dismiss an anomaly because it complicates a preferred theory. It simply finds the patterns. And the patterns it found were not subtle. Let's walk through the evidence the way GROK processed it, because each piece alone is interesting, but together they become something harder to dismiss. The evidence inside the layer, piece by piece. Start with the spherules. When researchers processed sediment samples taken precisely at the Younger Dryas boundary, they repeatedly found tiny magnetic and carbon-rich spherules, microscopic beads of material that only form when something is heated to extreme temperatures, and then cools so rapidly that it freezes into a perfect sphere before it can crystallize. You get these from high-energy cosmic events. Ordinary wildfires don't produce them. Volcanic eruptions don't scatter them across 4 continents simultaneously. The key word is simultaneously. A scattering of these spherules at one site might mean nothing, but a concentrated spike of them at the exact same boundary layer at sites thousands of miles apart. That is a different kind of evidence entirely. That is the difference between a coincidence and a signal. Then there are the nanodiamonds. Researchers pulled diamonds out of the boundary layer, nanoscale diamonds, including a particularly rare variety with a hexagonal crystal structure instead of the standard cubic form. On Earth, that hexagonal variety, known as lonsdaleite, forms under the kind of shock pressures and extreme temperatures you get from cosmic impacts. It doesn't form in wildfires. It doesn't form in floods. It forms when something moving at interplanetary velocity compresses rock so violently that carbon atoms rearrange themselves into a harder configuration than ordinary diamonds. Finding them concentrated in a single thin layer dated to the same event at multiple sites is not easy to explain away. Then there is the melt glass. At several sites, teams found tiny fragments of glass that, based on their chemistry and molecular structure, could only have formed at temperatures far exceeding anything a surface wildfire or volcanic event could produce. These are temperatures associated with cosmic impact events, the kind of heat generated when something from space either strikes or detonates in the lower atmosphere directly above a landscape. The melt glass found at Abu Huraira, an ancient site in Syria, is particularly striking. It suggests that whatever happened wasn't a single localized impact in North America. It was hemispheric. Multiple events, multiple regions, perhaps a fragmented object delivering a barrage rather than a single blow. And then there is the platinum. If the nanodiamonds are the most scientifically exotic element of the boundary layer evidence, the platinum anomaly may be the most viscerally compelling. Platinum is rare in Earth's crust, vanishingly rare, but it is relatively common in certain kinds of extraterrestrial material: asteroids, comets, cosmic debris. If a large object from space either vaporized in the upper atmosphere or struck the ice sheet above North America, you would expect it to leave behind a faint but measurable dusting of platinum settling across the landscape beneath the impact zone. In the Greenland ice core, designated GISP2, one of the most precisely dated climate records on Earth, where each layer represents a single year sealed and undisturbed in ice, researchers found a sharp platinum anomaly locked in precisely at the onset of the younger Dryas. Not near it, not around it, precisely at it. The same platinum spike has since been confirmed at numerous sites across North America. The same chemical fingerprint, the same timestamp, showing up again and again across an entire continent, locked to the same moment in time. When GROK cross-referenced the geographic distribution of every confirmed platinum anomaly against the dating of the boundary layer at each site, the pattern that emerged was not regional. It was continental, possibly hemispheric, the kind of distribution that doesn't come from a volcano or a flood. The fire that changed the atmosphere. Now add one more layer to what GROK was processing, because the physical materials inside the boundary layer are only part of the story. When researchers examined ice cores and sediment records from around the world at the younger Dryas onset, multiple teams reported a sharp peak in the chemical markers of burning. Charcoal, soot, carbon residue from the combustion of vast amounts of vegetation. Some studies described it as one of the most intense episodes of biomass burning in the entire geological record of that era, with fire signatures appearing on multiple continents at roughly the same time. Think about that for a moment. Not fires, not regional fires, global fires, or something close enough to global to leave the same chemical fingerprint in the ice and sediment of continents that share no geography. And here is why that matters for the climate question, the one that started this whole story. If enough soot and smoke and pulverized debris gets thrown into the upper atmosphere simultaneously, it dims the sun. Not permanently, not catastrophically in a civilization-ending sense, but enough. Enough to cool the surface, enough to interrupt an established warming trend, enough to throw the climate into reverse for over 1,000 years while the atmosphere slowly clears. This is sometimes called impact winter. The comet or cometary fragments in this model didn't have to cool the planet by raw force. They set the world on fire, and the fire did it for them. When GROK ran the atmospheric modeling parameters, the estimated volume of combustion byproducts, the projected dispersal patterns at stratospheric altitudes, the thermal feedback effects on ocean circulation, the output aligned with the observed duration and intensity of the younger Dryas cold period in a way that the meltwater hypothesis has struggled to match precisely. The meltwater alternative, and why the numbers are tightening. It is important to be honest here, because this channel doesn't traffic in false certainty, and neither does good science. The mainstream explanation for the younger Dryas has always been the meltwater hypothesis. As the great North American ice sheet melted, it created an enormous inland lake of glacial freshwater. At some point, the theory goes, that lake catastrophically drained into the North Atlantic. Freshwater is lighter than salt water. Dump enough of it into the ocean, and you can disrupt the Atlantic thermohaline circulation, the great conveyor belt of warm and cold water that keeps Northern Europe and North America mild. Shut down that circulation, and temperatures plunge. It is a reasonable model. It has been the textbook answer for a long time, and a significant number of respected scientists still favor it. But here is what the meltwater hypothesis has always struggled to explain. How do you get a meltwater flood that leaves nanodiamonds in Arizona? How does a sudden freshwater pulse produce a platinum anomaly in Greenland ice? How does disrupted ocean circulation melt rock into glass in Syria at the same moment it cools the climate in North America? How does a flood on one continent produce synchronized fire signatures on multiple continents simultaneously? The meltwater hypothesis explains the climate. It doesn't explain everything else in the boundary layer. And it is the everything else that GROK was built to contextualize. When the AI integrated the full dataset, climate proxies, chemical signatures, impact markers, fire records, geographic distribution, and precise dating, the meltwater hypothesis accounted for a portion of the signal. The cosmic impact hypothesis accounted for more of it, significantly more. The fragmented comet, the model that ties it all together. Here is the picture that emerges from the complete analysis, and it is a picture that has been gaining traction in the scientific literature independent of any AI analysis. The culprit most likely was not a single solid asteroid the size of a mountain. The absence of one massive crater in North America has always been the strongest argument against a simple impact scenario. But the impact hypothesis has evolved. The model that fits the evidence best now involves something different. A large comet, perhaps one of the most massive objects to approach Earth in tens of thousands of years, that had already begun to fragment along its orbital path. Think of the comet not as a single bullet, but as a shotgun blast, a dense swarm of fragments ranging from city block-sized pieces to particles barely larger than sand, all arriving in the same narrow window of geological time as Earth crossed through the debris field. Multiple fragments, multiple airbursts, multiple impact points scattered across the northern hemisphere, some of them detonating in the lower atmosphere with enough thermal energy to ignite continent-scale wildfires below, some of them striking directly into the kilometers-thick Laurentide ice sheet that covered much of North America, vaporizing instantly, leaving no crater because the ice absorbed and then melted away the evidence over the centuries that followed. This model explains the absence of a single crater. It explains why the boundary markers appear on multiple continents simultaneously. It explains the melt glass in Syria, and the spherules in Arizona, and the platinum in Greenland ice, and the nanodiamonds at sites across North America. It explains why the fire signatures appear globally rather than regionally. And it explains the three simultaneous catastrophes we started with: the abrupt climate reversal, the megafauna extinction, and the collapse of the Clovis culture. Not three separate events with three separate causes, but three faces of a single violent moment. The day the sky delivered a barrage that set the world on fire, poisoned the atmosphere, and left behind a thin black stripe of sediment as the only visible monument to everything that was lost. What this means for the Clovis people. There is a human dimension to this story that tends to get lost in the science, and it deserves a moment. The Clovis people were not primitive. They were skilled, highly mobile hunters who had refined their toolkit across generations into something remarkably effective. Their fluted spear points were precision instruments, engineered for bringing down the largest game on the continent. Their culture had been stable and widespread for centuries. Archaeological sites across the American Southwest, the Great Plains, the eastern seaboard. Wherever researchers dig at the right depth, the Clovis signature appears. These were not a small, isolated group clinging to survival in one corner of a continent. They were the dominant human presence across an entire hemisphere. Think about what that kind of cultural stability actually means. Generation after generation, the same tool designs, the same hunting methods, the same deep ecological knowledge passed from parent to child, grandmother to grandchild, across what must have been hundreds of years of continuous practice. The Clovis fluted point isn't the product of one clever person's innovation. It is the product of a culture so successful and so stable that it had no reason to change. And then it changed instantly. When the mammoths and the other giant animals disappeared, the Clovis people didn't just lose food sources. They lost the entire ecological framework their civilization was built around. A spear point designed for mammoth hunting is useless in a landscape that no longer contains mammoths. A set of knowledge, passed down across generations, about migration patterns and watering holes and herd behavior. All of that became irrelevant in the space of a single human lifetime. The children who survived whatever happened at the younger Dryas boundary grew up in a world that bore almost no resemblance to the one their parents had been trained to navigate. There is a word for that kind of rupture: trauma. Not just physical survival, but the psychological and cultural devastation of watching an entire way of life become extinct alongside the animals that made it possible. The Clovis culture didn't fade. It didn't gradually transform. It disappeared from the archaeological record with a speed that mirrors the extinctions it depended on. If the cosmic event model is correct, if a fragmented comet tore through the sky above North America, triggering wildfires, freezing the climate, and collapsing the food web in the span of a single terrible season, then the Clovis people were not merely hunters who ran out of prey. They were the witnesses to the end of a world. They watched the sky burn. They felt the cold descend. They searched landscapes suddenly emptied of the creatures their entire existence was built around. And most of them did not survive to describe what they saw. Whatever oral traditions they might have carried forward, whatever stories they might have told their children about the day everything changed, were lost along with everything else. The silence above the black mat is not just the absence of bones and tools, it is the absence of memory. The debate that GROK may have settled. Here is the honest state of the science as it stands, because this channel owes you that. The younger Dryas impact hypothesis has not been unanimously accepted. There are still respected researchers who favor the meltwater explanation. There have been attempts to replicate some of the boundary layer findings that produced inconsistent results, which in science is always a serious concern. Critics have argued that some of the impact markers, the spherules in particular, could form through ordinary processes rather than cosmic events. These objections are real. They deserve to be taken seriously. But here is what has changed. The evidence has not weakened under scrutiny. It has grown. With each new round of sampling, with each new site analysis, the suite of impact markers keeps showing up. The platinum anomaly has been confirmed at more sites. The nanodiamond findings have held up at multiple independent labs. The synchronized dating across continents has only tightened. An idea that was once dismissed as fringe has been pushed, slowly and stubbornly, toward the center of serious scientific conversation. What GROK contributed was not a single dramatic new discovery. What it contributed was the ability to see the entire data set at once, to hold every confirmed site, every chemical signature, every dating anomaly in simultaneous view, and identify whether the combined pattern was internally consistent with a cosmic event or more consistent with terrestrial processes alone. The answer it returned was not ambiguous. The pattern of evidence in the younger Dryas boundary layer is not consistent with any known terrestrial process. It is consistent with a large-scale, multi-point cosmic event delivered in a narrow window of time approximately 12,800 years ago. The synchronicity of the markers across continents, the suite of exotic materials present, the correlation with the onset of the climate reversal, taken together and mapped against every known alternative explanation, the cosmic hypothesis best accounts for the complete data set. For a growing number of researchers, the question has quietly shifted from, did something cosmic happen, to how large was it, and exactly how much of the catastrophe did it cause? The Tunguska Reminder, and why this should keep you awake. In 1908, a cosmic object, probably a fragment of a comet no more than 50 meters across, exploded in the atmosphere above a remote stretch of Siberia near the Tunguska River. There was no crater. There was barely any physical evidence of a solid impactor at all. What there was, an airburst powerful enough to flatten approximately 800 square miles of forest, snapping millions of trees at the trunk as though they were matchsticks. That was one small fragment over an uninhabited wilderness. The world barely understood what had happened for decades afterward. The boundary layer beneath the black mat may be the fossilized record of something that dwarfs Tunguska by orders of magnitude. Not one fragment, but dozens or hundreds, delivering Tunguska-scale energy across hemispheres simultaneously, touching off wildfires from the American Southwest to the Middle East, pumping enough debris into the upper atmosphere to dim the sun for a generation, and leaving behind a thin, dark stripe of evidence that researchers are still arguing about 12,000 years later. The sky is not as safe as it looks. The Earth has been ambushed before, and the record of that ambush is buried in the dirt at a depth you could reach with a shovel. The planet's diary. The next time you stand at a cliff face or look down at a riverbank and spot a dark line in the sediment, remember what you are looking at. The planet keeps a diary. Layer by layer, year by year, it records everything that happened. The floods, the droughts, the ice ages, the impacts. One of the oldest entries in that diary, written 12,800 years below the surface, describes a single terrible season. A season when the sky lit up with fire, when giants vanished from the earth, when the people who had built their world around those giants watched everything collapse, and most of them did not survive to tell the story. The Ice Age didn't just end, it was ended. And in a thin black stripe of sediment buried beneath your feet, the evidence is still there, waiting for anyone patient enough to look. GROK looked, and what it found doesn't leave much room for debate anymore.